This video is about machine learning and what Parallel Studio has to offer. But before we jump into the Parallel Studio machine learning, let's talk about the difference between machine learning and just plain algorithms. Here at GoParallel, I have talked many times about optimizing algorithms. Normally, the optimizations I achieve are through parallelization techniques. I do this because this is GoParallel, and that's what we stress here. And while machine learning techniques are comprised of algorithms, one or more algorithms to be specific, and these algorithms must also be optimized. But machine learning gets better in a different way. It learns as it goes. Machine learning gets better by experience. As the algorithms are exposed to new experience and new data input, it gets better and better. So machine learning optimization is based on two things. First, the normal algorithm optimization, and second, the learning process. There are three major types of machine learning. First, I'd like to point out is called supervised. For supervised learning, for every input, you have a known outcome. For instance, if you're creating an email filter and you have a list of words that you definitely don't want to allow through, maybe they're profanity and maybe they're offensive or something like that, you would label those as completely unacceptable. Other words such as beautiful and the and a and words that you definitely want to let through, you would label those as perfectly okay. So all words or phrases or however you're doing it would be labeled either appropriate or inappropriate. And then you would train your machine learning algorithm so that it would learn how to distinguish between the good and the bad. So that's supervised learning. Before the training, you know what acceptable and unacceptable is, and based on that, the training goes forward. Unsupervised is different in that you're not telling it what is acceptable or unacceptable, good or bad. It's actually going to use a clustering approach to put things in little groups that it's able to find. Now, the reason that this is very applicable is because you don't always know what's good and bad. You don't always know what the groups and categories are going to be. You don't always know sort of how things are going to break down. So unsupervised learning is extremely important too. The third type of machine learning I'd like to talk about is reinforcement. Now, this is really different than supervised and unsupervised. It's almost like a survival of the fittest. Basically, the algorithm says, how can I gain maximum advantage? What do I need to do to win the most points? It's basically a point-based system, and it will figure out what its best approach to getting the highest score or doing the best job will be. So you might be asking the question, why is machine learning so important? Well, there's one very simple answer. Big data. Big data comes from all of the number of people on the internet. They're all doing things. They're making decisions. They're going from this page to that page. They're buying this, then they're buying that. Especially when you consider what you get from sources such as Google search and possibly Facebook. This provides a huge opportunity for e-commerce providers who are on the internet trying to sell things or sell services. The first step in taking advantage of this opportunity is to extract value from the data. In other words, try to figure out what they're doing. If you can figure out what they're doing, if you can get the right information, you can more accurately predict customer behavior and potentially sell more product and services. So far, we've been talking about machine learning as if it were one algorithm. However, that's really not true. It's an umbrella over many algorithm categories. So let's talk about those right now. The first is data analytics, which in my next video I'm going to focus on. And that's where you can take the big data and get some sort of a reasonable understanding of what's going on. Then comes brain-machine interfaces, and these are the kinds of things that maybe learning disabled people use, maybe the EEGs on your head that figure out what you're trying to think of. And I've had students actually steer small devices with those on their heads. Computer vision is obviously a very big one. Or this allows, say, for instance, robots to move through a room, to walk around different things and avoid obstacles. Computational is pretty straightforward. That's things such as Fourier transforms, and I've talked about that in the past. Natural language processing is pretty important. That takes text and derives some sort of meaning from the text. For instance, Google is always spidering web pages, and when they do, they not only look for keywords, but they look for meaning. Medical diagnosis, now computers are doing it more and more. Image and pattern recognition. A good example of this is Facebook, where they can tag you in a picture if it recognizes you as one of the friends. And lastly, search ranking, very important for companies such as Google. My conclusion, Parallel Studio offers a wide range of machine learning algorithms, really huge, really extensive. My next video will cover Data Analytics Acceleration Library, or DAL, and how these machine learning algorithms can be used for DAL. Please try to catch that video.